Section we're going to be looking at the coordinate proof. 5.1 has two parts. It has the mid-segment theorem and the coordinate proof. We're going to be looking at the coordinate proof for this part. Our learning goal is to position figures in the coordinate plane for use in coordinate proofs. Prove geometric concepts by using coordinate proof. So before today, if you remember, we looked at algebraic proof a couple months back, and we used algebraic proof to prove the steps for solving equations, and we looked at the geometric proof, and that was the proof used to prove properties about geometric figures. Today we're going to be looking at the coordinate proof and how that works. So a coordinate proof is a style of proof that uses coordinate geometry and algebra. The first step of a coordinate proof is to position, so this is step number 1. To position the given figure in the plane. You can use any position, but some strategies can make the steps of the proof simpler. So let's practice what positioning means. Example 1, positioning a figure in the coordinate plane. Position a square with a side length 6 units in the coordinate plane. So when you position a figure, you want to make it obvious that the side lengths are 6. So if I put this corner at the origin, then it'll be easy to see by reading the axes that the side lengths are 6. And let me show you what I mean by that. This is the y-axis and this is the x-axis. Now, if I count, if each box is 1 unit, I have 1, 2, 3, 4, 5, 6. And going this way, I can move this a little bit. There we go. And going horizontally, we have 1, 2, 3, 4, 5, 6 also. So I can clearly see that this square has side length of 6 units because of the way I positioned it in the coordinate plane. So that's what positioning means. It's putting a figure on the coordinate plane such that you can tell what the side lengths measure. Let's try another one. Position a right triangle with leg lengths of 2 and 4 in the coordinate plane. Hint. Use the origin as the vertex of the right angle. So here we have a yellow triangle. It's a right triangle. The right angle is obviously right here. The hint is telling us to position the right angle at the origin. Gotta move a little symbol for right angle. Awesome. So let's check 1, 2, 3, 4, 1, 2. So we positioned it like we were supposed to. Once the figure is placed in the coordinate plane, you can use slope, the coordinates of the vertices, the distance formula, or the midpoint formula to prove statements about the figure. So when you're positioning and you're using the coordinate proof, you're going to be using a lot the slope formula. You're going to analyze the coordinates. You're going to use distance formula or midpoint formula. You've got to be ready to use any of these. And please remember, you're going to have to memorize the midpoint formula and the distance formula for the EOC, as well as the slope formula, because there's no reference sheet provided this year. So, as a reminder, the distance formula is d equals square root. You might want to write this down somewhere so you can go ahead and start studying that and memorizing it. x2 minus x1 squared plus y2 minus y1 squared. The midpoint formula is x1 plus x2. So here we're adding the x coordinates. Divided by 2, comma, y1 plus y2 divided by 2, close parentheses. So if you notice, the midpoint is an ordered pair. That's why there's a comma between it. And the slope formula, of course, is y2 minus y1 over x2 minus x1. Now, example 2, writing a proof using the coordinate geometry. Given rectangle ABCD with A coordinates A00, B40, C410, and D010. Prove the diagonals bisect each other. Okay, the diagonals are these blue lines. Diagonals are lines that go from vertex to vertex. We want to know if these diagonals bisect each other. Remember, bisect means that you split it into two congruent parts. It's split into two congruent parts when you have a midpoint. So here, for AC to be bisected, that means that this must be a midpoint for both segments. How do we prove this is a midpoint? Well, we need to see if we do the midpoint formula for segment AC, if we get the same midpoint when we do the midpoint formula for DB. So let's do the midpoint formula for AC. So we're going to calculate midpoint for AC. So remember, for midpoint we do x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So we have A is 0, 0, and C, so let's write down the coordinates. A is 0, 0, and C is 410. Let's label our points. So our midpoint would be x1 plus x2, which is 0 plus 4, and that's just 4, divided by 2, comma, 0 plus 10 is just 10, divided by 2. If we reduce that, we get 2, comma, 5. So we got the midpoint for AC as 2, comma, 5. Now let's see if we get the same midpoint for DB. If we get the same midpoint for both, then we know that those diagonals indeed do bisect each other. So let's calculate the midpoint for DB. So D is 0, 10, and B is 4, 0. So this is x1, y1. And over here we have x2, y2. So we have 0 plus 4 is just 4, divided by 2. And 10 plus 0 is just 10, divided by 2. And when we simplify that, we get 2, comma, 5. And notice we got the same midpoint for both AC and DB. So that means this is the midpoint for both. And since it's the midpoint, that means that it bisected the segment into two congruent parts. So the diagonals do bisect each other. Awesome.